In this example, we're given this function g of x, and it appears to be a quadratic function. We have this x squared for our quadratic term here, and this x for our linear term. And we've got m and a 7n, which kind of combine to make our constant. So you'll notice that x is going to be our independent variable, but we also have a couple of these variables, m and n, for which we're going to find their values. So remember that when we graph a quadratic function, its graph is going to be a parabola, and we know that the vertex of that parabola will be the ordered pair 3, -7. So how can I use that information to go ahead and find the values of m and n and write this quadratic function? Well, if you'd like to pause the video and give it a try, go ahead and do so, and then come on back and we'll work a solution together. All right, so to facilitate a solution here, we need to know and understand a few concepts that are going on here. So we know that the vertex is this ordered pair 3, -7. Okay, well that's really good. That means that this 3 is the x value and this -7 is the y value. Okay, well that indicates that whenever I plug in 3 into my function, I'm going to get a -7 out. Okay, well that seems pretty good. Also, since this is the vertex, I know that I can determine the vertex of any parabola if the equation here or the function is written in standard form. The x value is going to be the opposite of b over 2a, and the y value will just be whatever I get when I plug that value into my function. Okay, and this we know is going to be 3, and this we know is going to be -7. So we need to use some of these relationships together, kind of in tandem. We have this guy, we also have this guy. We're going to use them together in order to come up with a nice solution. And so let's start by using this first one. I'm going to plug 3 into the function, and so I'm going to plug 3 in for x here and x here, which means I'm going to have an m and an n hanging around, but I know that expression that I'm going to get is going to be equal to -7. So let's go ahead and take a look at that. So I have my -2 right here, and I'm going to plug in 3, so 3 squared plus 6n times 3, and we have plus m minus 7n, and that equals that y value here of -7. Okay, well let's simplify this a bit. 3 squared, I'll do the squaring business first, is 9, and then -2 times 9 is -18, and then 6 times 3 is 18n, plus m minus 7n equals -7. I can clean this up a little more. I'll write m, let's see, plus 11n equals, and when I add 18, I'll get 11 right here. Okay, so here's one nice equation that I have. It's in terms of just m and n, and so I know this relationship holds for m and n. All right, so now let's go back to our vertex information. And so I can determine the vertex of any parabola as long as its function here is written in standard form by taking the opposite of b. So what is this b? So this is going to be the coefficient of the linear term, because remember, quadratic functions in standard form are written ax squared plus bx plus c, and the b then is, like I said, the coefficient of the linear term, and the a is the leading coefficient here. And I know those values. Right up here, my b value is going to be 6n, and my a value is going to be -2. Okay, well I can use this information, plug it in right here, and set it equal to 3. So the opposite of b over 2a. Well, the opposite of 6n will be -6n over twice my a value, and a is -2. So twice my a value, and I know that this is going to equal, well, 3, because that's the x value in my vertex. Okay, so -6n over -4 equals 3. So I can go ahead and multiply both sides by this -4, kind of cancel that stuff out, and I get -12. And when I divide by -6, yeah, n equals 2. And that's great, because if I know that my n value is 2, it looks like I can just go ahead and plug it right there. So m plus 11 times 2 equals 11, And you'll see this is going to come out really nicely. I can subtract 22 from both sides. So m equals negative 11. All right, so I have both of my values. N is 2, m is negative 11. Let's just go ahead and plug those back into my original function g of x, and let's just figure out what this function is going to be. All right, so g of x was negative 2x squared plus 6nx plus m minus 7n. And let's go ahead and just plug in everything I know. So g of x equals negative 2x squared plus 6. N is 2. M is negative 11. And we can simplify all of this for our final product here. So negative 2x squared plus 12x. And it looks like a negative 11 with a negative 14 will make a nice negative 25. So here is going to be our function. And here was the original that included the m and the n. We knew the vertex was 3, negative 7, so we were able to solve for m and n by setting up nice equations based on the relationships that exist between, the function in standard form and the vertex there. And then we were able to put it all together, and here's my function.